following organizations have provided funding for this Into the Outdoors television series.
We know you can't put corn on the cob in your fuel tank. But what properties make this a prime feedstock for creating biofuels?
One of the main ones is its starch content. So the starch content of corn as it comes into our plant is about 60 to 65%. Another reason is it's very plentiful in this area and it's renewable, so we can put it in and grow it within one season. So one kernel of corn of this size planted into the ground can multiply into 800 kernels of the same size. What's really unique about the corn, though, is that we're able to use every component of the corn, not just the starch. So not only do we make ethanol, but after we pull the ethanol out of the material, we have protein and fat and fiber left that all become components of animal feed.
First, local farmers deliver corn to our ethanol plant. Once here, we weigh the loads on large, truck-sized scales and take samples of the corn to test for quality. Then, the trucks proceed to the load-out area and dump the corn into this underground system. Next, conveyors carry the corn to these concrete silos and steel bins. You mean to tell me that these things are full of corn?
Absolutely. We do have corn in both of these silos, about 500,000 bushels of corn in each silo.
500,000? All right, we saw the corn go through the grate and onto the conveyor belt. What happens next?
A bucket elevator takes the corn all the way to the top of the silo. And through the silo, we've got a piece of equipment that it's called a scalper. A scalper basically segregates the corn from foreign materials, like rocks, gravel, or whatever. So once it's gone through the scalper, then we're ready to feed it into the hammer mill. And in the hammer mill is actually where the corn gets converted into flour. So the hammer mill is a mechanical piece of equipment that converts kinetic energy into repetitive blows to the grain, to the corn kernel. And with multiple impacts that corn kernel sees within the grinding chamber, it basically converts into smaller, finer particles, which we call it corn flour. And then the flour gets conveyed across the street into our process building where the process of making ethanol happens.
All right, now that we've literally crushed the corn, let's explore some of the chemistry and biology that goes into making this into biofuel. Let's get cooking.
Thomas, you're right. We actually do cook a material as it comes into the process.
How does it start?
So corn, as we receive it, doesn't have starch that we can access for fermentation. We actually have to break down those starches into a usable format. We do that in our cook process by adding heat, enzymes, and water. Enzymes are the catalyst which jump starts our whole reaction. So we use two enzymes in our cook and fermentation process, and they are both called amylases because they break down sugars. The first one that we use in the cook process is called an endoenzyme because it only breaks down the sugars in the middle of a starch chain. But the enzyme that we add when we get to fermentation is called an exoenzyme, and it's called a glucoamylase because it only eats off the terminal end glucose. So this is what we start out with, pure starch in our corn flour, and this is what we end up with going into a fermenter, mash. Have you heard of yeast before?
Oh, doesn't that go into bread?
It does, actually. Fermentation is similar to baking bread. And yeast, to me, are the cool cats of the whole process because they are the workhorse. Without the yeast, we would not have ethanol. So the yeast are a living organism just like you and I. If a human body needs it, then the yeast need it. So we give yeast vitamins and minerals. Much of that comes from the corn itself, but we also add a nitrogen source in urea as the main nutrient for the yeast. They perform best when they're not too hot or not too cool. So we actually run fermentation at a very narrow range of about 90 to 93 degrees Fahrenheit.
So what do these little yeasts look like?
They're microscopic little single-celled organisms that are oval-shaped, similar to a football. But you need a magnification of 100 to 1,000 times to be able to see the yeast cells. After fermentation, we extract the ethanol via a two-step process, the first of which is distillation. So we inject heat at the bottom of the column and our fermentation material at the top of the column. Ethanol has a boiling point of 173 degrees Fahrenheit. Water has a boiling point of 212 degrees Fahrenheit. So as we heat up the material, the ethanol vaporizes out the top of the column, and the water and the solids come out of the bottom of the column. So our distillation section actually utilizes 3 columns to make sure that we can get all the ethanol out of the process.
All of this is really interesting, but how does ethanol get into our gasoline plant and then into gas stations across the country?
I haven't the slightest idea, but you know what? I think this guy might be able to help us out.
I think I can help you figure this out.
Thanks.
From those big tanks, we'll load it into a rail car over there, and then it'll go to a terminal. And at the terminal, they'll put it in with gasoline.
Told you.
And gasoline with the ethanol will be shipped to the gas station where you would fill up your car.
You know, 10% still sounds like a delusion to me. I'm going high octane when I get my first car.
And you should, because there's more horsepower in octane. And ethanol is a great octane booster. And what it does is it takes away some of the petroleum that would have the octane, and it puts ethanol in its place. And then that is used in the chemical industry that can make plastics and other higher value products.
Time out. What's octane?
Octane is something that they measure in gasoline to reduce knocking in engines. And ethanol by itself has about 113 octane, and gasoline that you blend it into has about 84 octane. Well, you need to get up to like 89 or 91 before you put it in the engine. So when you mix it together, it gives you the 91.
That's cool of what's going into your car, but aren't you more worried of what's coming out of it?
And a higher performing and a better performing car will reduce the emissions coming out of the car. So ethanol does help with the emissions of the car.
I'm still curious about something. I mean, think about it. Where does all that leftover corn mash go? It has to go somewhere.
Yeah, but that's why we have to discover the rest of the story. See Mount Everest over there? Let's check it out.
That little Mount Everest, that's just a little bit of what we produce. So this product, the way we load it out of the plant is to load it out in 2 modes of transportation. First, by truck, semi-hopper trucks. This truck product stays mostly in the domestic market, fed to swine, poultry, and beef. The other mode of transportation is rail cars. We utilize the rail cars because we can ship the product faster and further. This product will get shipped to the river, the Mississippi River, to be offloaded onto barges. The barges then float down the Mississippi to be loaded onto large Panamax vessels that are shipped to China, Japan, Asia. We also will ship rail cars into Chicago to offload the rail cars into containers that we ship to Southeast Asia, primarily Vietnam, Korea, Thailand. Again, all of this product is a very nutritious product for animal feed, high in protein, energy, and fiber.
Whoa, so you really are helping feed the world.
Yeah, but all of this is dry. Didn't we see mash earlier? How to get from that mushy goo to this dry stuff?
We got to get that dried down in order to transport it.
Okay.
In order to do that, we further process the mash to remove a lot of the water, and then we send it through 2 sets of dryers to dry it down into a 12% moisture product.
No way, can we see it?
Yeah, we can see it, but it's really hot, so we're going to make it a quick trip.
Oh, sweet. See, the amazing corn kernel not only helps to power our vehicles, it also helps to feed the world.
Have you noticed anything today about the people working here? Women in the biofuel industry using science and engineering have gotten so far in this line of work. Anyone can do it. They just have to work hard and continue studying.